All right, so who does not have, rather, if you do not have Python 3.6 installed, you're not sure if you have it installed, if you could put up a red sticky, or if you've already talked to a TA about the situation on your computer, that's fine as well. If you don't have Python 3 installed, specifically 3.6, there are going to be some bumps, some hiccups during this, because I'm using Python 3 syntax. Python 2, Python 3, they are different programming languages. They are extremely similar, but there are some big differences between them. In that Python 3 is backwards incompatible with Python 2. If you've got Python 2 code, you can't run it on 3 and vice versa. You can run code on both, but it's got to be a subset of the two. 3.6 added some new features that I will be using today. So if you're on 3.5 or earlier, then you're maybe going to have some struggles as well. So if you cannot access the website, that's intro2017.trey.io, intro2017.trey.io, please put up a red sticky, let a TA know. There were internet issues yesterday. I think they fixed them today, but we will find out. If they haven't, you can always bring up the website on your phone. There actually are a couple things you need to download there that we're going to go over right now, but for the most part, you can bring it up on your phone. Okay, let's actually go over those things you need to download right now, just to make sure that if we have internet issues, we get them settled the first 10 minutes here. So on the website, on the very home page, if you could scroll all the way down to the bottom, I'm going to bring that up real quick here. All the way down to the bottom of the page, and click on each of these files and download them somewhere. They can be in your downloads folder, wherever you want them to be. You're going to copy paste those every once in a while throughout the day. Now, we only have 3 hours together, and it's difficult to learn a new programming language in 3 hours. It's difficult to learn programming in 3 hours. So we are going to try to make some progress, but it's going to be difficult progress. You will have hopefully written code by the end of the day. I can't promise you how many lines of code you will have written, but you will have written at least a line of code. Hopefully it's a line of code that does something. Maybe not the right thing, but something. So when doing a tutorial or any kind of class for any audience, I like to know who I'm working with. And I don't know any of you yet. So I'd like to know who has been to PyCon 3 or more times, including this year. You've been to PyCon 3 or more times. Okay, no one in the room. That's good. Not that I would feel bad if any of you have been here a lot. PyCon's a wonderful place, but I was assuming you're pretty new to PyCon. Who's been to PyCon 2 times, maybe last year and this year? Been to PyCon this year and another year. Okay, who's their first PyCon this year? Excellent. Awesome. So another set of questions. Who has written in any programming language over 1,000 lines of code? Okay, more of you than I expected. So we might have different definitions of new programmers here, but that's okay. So who has written between 100 and 1,000 lines of code? Okay. Ever in any programming language, 100 to 1,000 lines of code. Okay. Who's written less than 100 lines of code in any programming language? You're pretty sure you've probably written less. Okay. So overall, I have the feeling that we might be a little bit more experienced than I'm expecting here. That doesn't necessarily mean you're not going to struggle, because often things go faster than we'd expect them to go in terms of learning a new programming language. In Python, who has written over 1,000 lines of code? Okay. All right, so at least we're, for the most part, pretty new to Python here. All right, at this point, actually, I would like to bring out the rubber ducks, I think. I didn't ask this beforehand. I don't want to put any of you on the spot. Do any of my TAs want to explain rubber duck debugging? Okay. Yeah, Anna doesn't have a mic, so this might not be on the video. Sorry.
I'll just try to speak out loud. So, who of you know what rubber duck debugging is, or who of you have heard about it? Not many. So, you all know those little bathtub rubber ducks, and the concept is that you put a rubber duck on your desk and you explain your programming problem to it. It's do that, but it's actually just like explaining something to another person. The rubber duck just can't talk back. And by speaking your problem out loud, you will either find the solution, because your mind starts digging more into the issue, or you will at least be able to phrase it more precisely so you can Google it. Sometimes when you have programming issues and you don't quite know what the problem is, you can't type a whole paragraph into Google. When you Google something, it needs to be really precise. And so by explaining it to your rubber duck, you'll kind of realize in your mind a little bit more in detail what the actual issue is, and then it'll help you with your programming problem. And when you walk through the expo hall, some of the sponsors usually have those rubber ducks, so I can highly recommend grabbing one and putting it on your desk and actually trying it out, because it does work.
So I asked someone else to explain it so that you would believe that it's a real thing. And it didn't just make that up. It is on Wikipedia. So if you go to Wikipedia, there is a rubber duck debugging article. This is a real thing. So Charlie's currently passing out rubber ducks to you. You all get a rubber duck today. You will not need these rubber ducks. Some of you get pairs. It's for pair programming. You will not need these rubber ducks in the room today because you have teaching assistants, and they can be your rubber ducks. Teaching assistants who are here right now, we've got Anna Salsky, Kojo, Melanie, Charlie, who's currently walking around with ducks, and I think we might have another TA come in later to help us out. So if you need help today, we're going to use a sticky system. During the exercises, and we will have multiple exercise breaks, put up a red sticky like this to note that you need some help. We use stickies because if you are raising your hand, it is difficult to type, unless you are good at one-handed typing, but it is difficult to do one-handed typing. So we're using stickies so that you can easily type while asking a question at the same time, or wanting someone to come over and be your rubber duck to just, be there as you try to walk through the problem. We have plenty of TAs, so do not be afraid to use your red stickies. We are happy to be your rubber ducks. All right, so let's get started here. I do not use slides when I teach. So we are going to be live coding. You do not need to be typing in everything that I type in. Everything I type in, for the most part, is going to be on the website. You can look at it afterwards. I am going to pass the torch to you every once in a while. We're going to work through exercises, and that is your turn to type. And at that point, you'll work through exercises. Afterwards, we might go through one together if we have time. You're welcome to go look on the website, to Google things, to go to Stack Overflow. That is not cheating. In the real world, probably half of the code that you write is copy-pasted from Stack Overflow. Some people may not like the fact that I say that, but I don't think they would deny that it's true. So in Python, we can get to Python by opening a command prompt, typing Python 3.6. There's various ways to do this. On Windows, Mac, and Linux, it's all a little bit different. If you can't get to your Python REPL during the exercise break, put up a red sticky and ask a TA for help, please. We have math. We've got numbers. We have arithmetic with both integers and decimal numbers, which we call floating point numbers for weird historical reasons. Yeah, you should. Thank you for pointing that out, Kojo. You could just look at rubber ducks all day, but it's nicer to look at code. So 2 plus 2 is 4, 1.4 plus 2.25. Still have a website up. Thank you. Okay, now we can see my code. So Python has math. I typed Python 3.6 to get into this thing. So this is the Python shell. We also call this the Python REPL. Does anyone know what REPL stands for? So I don't think my TAs know what REPL stands for either. So REPL, I looked this up at some point. I can't remember whether it's read evaluate print loop or read execute print loop. Python reads what you are typing. It executes what you're typing when you hit enter. It prints out the result, and then it loops, meaning it is waiting for us to start over, to start typing again and do something else. So this is the read, execute, print loop, the REPL. Python shell, Python REPL, either of those names. All right, 2 divided by 2. What do you think this is going to give me? What's your guess? 1, all right. 3 divided by 2. What do you think? 1.5. So Python 3, Python 2, this changed a little bit. Python 3 does what we'd expect here. 3 divided by 2 is 1.5. If you don't get 1.5 later when you type this, you're in Python 2. We need to jump into Python 3. If you do want to round things down, you can use //. I don't know why you'd want to do that, though. What's your guess? What do you think this might do? 2 * 10. 2 raised to the 10th power, 2 raised to the power of 10. So maybe this is an exponent? Yeah, so 1024, that's 2 to the 10th power. What do you think this is going to give me? An error? Maybe it'll break my computer? Hopefully it doesn't break my computer. I want to go at least 20 minutes without breaking my computer. Gives me a really big number. So Python does not have integer overflow, which some programming languages have. We have really big numbers, and that's fine. So one of the great things about Python, as opposed to other programming languages you might jump into, you might start learning, is it tends to be a little bit easier to work with when you're getting started. We don't have to worry about problems like that really big numbers might not work. All right, so I know that was really brief here, but I'm going to pass it to you now. It is your turn to now go to the REPL and type some things in. So if you could go to the website, it's intro2017.trey.io and go to introduction and that first your turn REPL. If you could go there and work through, we've got 4 exercises. By the way, I do not plan on you being able to get through all of the exercises in any given exercise section. These are here for you to work through after the tutorial. If you do get through all of them, if you're fast at working, that's fine. Put up, actually, if you do get through all the exercises, if you could put up a yellow sticky, I don't know what color this is, the sticky that's not red, if you could put that up on the top of your laptop if you get through all 4 of the exercises, that would be excellent. Then I know that it might be time for us to move on. If you need any help at all, whether bringing up Python, getting into the REPL, typing something out, or figuring out what one of the exercises means because it's not worded very clearly or you're unsure, please put up a red sticky, and one of the TAs or myself will float around in the room to help you out. Yeah.
Is everyone able to get to the website? Is that fine for everybody?
So I don't see any red stickies. A reminder that we're happy to be your rubber duck. If anyone is having trouble getting the files on your computer, I've got them on a USB stick. You having trouble? Excellent. Yep. Yeah, besides those files, you should be able to access the website on your phone. All right, we're going to move on to the next section at this point. So hopefully you got to play around in the REPL a little bit. There weren't really any exercises there that we have answers to. That was mostly just playing. We will occasionally go through answers. Who is the type of person who likes to ask a lot of questions? Okay. If you are not the type of person who likes to ask a lot of questions, I would challenge you to ask at least one question today. If you ask at least one question today, I think we should have a question every 8 minutes or so. It's hard to do math in my head. I could use Python, but I don't even know what I'm dividing. Yeah, so we should have a lot of questions if you all ask at least one question today. If you're the type of person who asks a lot of questions, and you feel like you're the only one asking questions, pause for 10 seconds or so, and if no one's asked a question still, feel free to ask your question. All right, what do you think this is going to do? I'm going to type Trey. This is not a number. What's your guess? An error? Yeah, Python does not understand my name. I am not built into Python. So if we want to type text at the Python REPL, we can put it in quotes. This is a string. Strings are the way that we represent text as opposed to numbers. Python does not care if you use double quotes or single quotes. So double quotes work, single quotes work. You have to make sure that you use double quotes and single quotes consistently, though. If you type PyCon starting with double quotes, ending with a single quote, that doesn't work.
Question though, when you
Yep.
use your double quotes, you respond to just the single text.
Yeah.
That's
That's a good point. So we put in double quotes there. It gave us back single quotes. I put in single quotes. It gave me back single quotes. So Python doesn't care at all what quotes we use. When it spits something back to us, it's going to spit it back in the way that it feels like it should. If I were to say, I don't know, it puts that in double quotes. It puts that in double quotes because it's got an apostrophe in there. And it decides, oh, it would be easier for me to show double quotes around that. If I put double quotes and single quotes, that's going to be hard for me to do. We're going to try that later, maybe. If I put double quotes and single quotes in a string, it will do something a little bit different. In fact, we'll get an error. That is not something Python can handle. If you wanted to do that, you have to put backslashes before those things. And then Python still decided to do something different. It put it in single quotes and put a backslash before that apostrophe. So Python does what it wants. Python does what it wants. We type in a string in one way, it's going to give us a string in whatever way it feels like giving it to us. All that we care about, though, is that it's a string. What would happen if I add a string and a number together? What do you think? What is your guess? Who thinks we're going to get a string back? Who thinks we'll get a number back? Who thinks we're going to get an error of some sort? Who thinks we're going to get something else? Okay, so we get an error. This is different between different programming languages. Python does not want us to try to use plus on strings and numbers. It doesn't know how to handle that. If we wanted to add to a string with something else, we have to add it to another string. Now notice it doesn't matter whether I'm using single or double quotes here. If you take two strings and you add them together, this is smushing them together. This is called concatenation. Concatenation basically just means you're taking two things and smashing them together. All right, Now it's your turn. So back to the website. This time we're on strings. So today, hopefully, you will get a lot of experience typing things, not just at the REPL, but in Python files. We will be making Python programs soon here. If you have any questions at all, put up a red sticky. If you get through all of these exercises, put up that yellow colored sticky. We're going to jump to the next section at this point. Any questions so far? All right, make sure you've got that one question that you're going to ask ready at some point. Okay, so let's jump back into this. All right, who has done, I want to say math before, but everyone's done some kind of math. Who's done algebra before? Who remembers algebra? X equals something, Y equals something, variables. So in Python we have variables as well. So I can say X equals 4, X times 3, and that gives me 12. I can take a bunch of variables and add them together as well. So this is not my packing list for Python. This would be a little light if this is what I was packing for Python. We've got some socks, shirts, shorts, and we add them together, we get clothing. What should clothing be here? Yeah, it's 4. So we can use variables as placeholders. Variables point to a thing, and that it's basically a placeholder for that thing. So if we've got the number 2, we can use the number 2, or the variable that represents that number 2, say socks here. Or we have the number 1, both shirts and shorts point to the number 1 there. All right, I'm going to throw it back to you at this point again. So lots of typing. I'm trying to make this as hands-on of a tutorial as possible. The reason for this is if I show you things and you don't type them, you haven't learned anything at all. You've seen me do something, but until you've applied something, you haven't learned it. So we're at your turn variables at this point on the website. If you have any questions, put up a red sticky. If you get through all 4 of these exercises, put up a yellow sticky. Right after this section, we're going to finally make our own Python programs. All right, I realize that wasn't very long, but we're going to get back to it. Any questions at the moment about anything we've done so far? All right. When you create a variable in what? Oh yeah, how long does it last? That's a great question. So I'm going to show some fancy stuff right now that you do not have to remember, but I do want to kind of drive home the point that how variables work here. So if you're debugging Python code, sometimes you might type in dir and run that. That tells you what variables are just kind of floating around in the ether. You never normally use this in your code, but if you're poking around, it can be nice to type in dir. This tells us we've got shorts, socks, shirts, clothing, and that variable x. So as long as we are in Python, all the variables we've made in the Python rep will stick around. Now what I just said is actually kind of a lie, but it's a lie that's difficult to explain the truth for. So if you're in a function, if you're in a class, if you're in some sort of structure where your variables are hidden inside that thing, they go away, they stop existing anymore once that function returns, once it's done being called. So variables have a scope. If you're interested in knowing how long variables stick around, I would look up variable scope Python on Google, and that's going to do actually a much more thorough version of explaining that than I just did. But yeah, variable scope is, and actually that's something I think I have done a chat on before, so I didn't introduce myself. My name's Trey. Hi. Nice to meet you all. I do a chat every week on Python stuff. I think I have little cards that say what the URL is, but you get to see my screen right now, so you can see the URL here. Weeklypython.chat. I do a chat every week on Python. I think I've done one on variable scope before where we just talked for half an hour about how variable scope works. Some of these are really advanced. Some of them are very simple. A lot of them are in between. So if you have questions, I would love to hear those questions because I usually take questions from people and turn them into chats because I can't come up with very good ideas for chats on my own. So weeklypython.chat is where you can find me after the tutorial. And please, I think you all have my email at this point, right? Did I send you an email? Okay. Feel free to email me after the tutorial as well and ask questions. But that doesn't excuse you from asking a question today. You still need to ask a question by the end of the tutorial. So I want to mention before we jump into Python programs, if we have variables like this and we wanted to make a sentence, we could say conference, a space, the year is really great. And I misspelled something. Oh, it says conferences. I'm going to just say conferences there. So this is PyCon 2017 is really great. Now notice I put a space here because if I didn't put a space, it smushes those two together. Python is literally doing what we asked it to. It's taking that word and that number, joining them right together. So this is called string concatenation. This is something we've already seen. You're probably going to use this in your Python programs that we're going to be writing here in a moment. I do want to show you though, if you're in Python 3.6, there's a new fancy feature called f-strings that allows you to type an F before that double quote or before a single quote. And you can put these little curly braces to put variables inside of your strings. So conferences year is really great. So this is called string formatting or string interpolation. It's basically a way to do what I think of us actually doing in my head, which is take a sentence and have little placeholders and stick those variables inside those placeholders in the string. So that is on the website. It's under the string formatting with f-strings section. We're not going to do exercises on that though. You might end up using this while you're writing Python programs. All right, so at this point, I am going to make a program. I'm going to make a program. You can follow along if you'd like, but during the exercises, you're going to do this as well. So I'm going to use Vim here. I'm using Vim, which is a fancy text editor that you can use from the command line. I'm using it because I'm on the command line, and that's all you're seeing. And since I'm screen sharing in a kind of funky way, I'm going to be using Vim. You can use Atom, you can use PyCharm, any text editor that is suitable for writing code. I'm going to make a program called greetings.py, and in it, I'm going to type the string hello world. I'm going to type Python 3.6 greetings.py. Now you could type Python 3, you could type Python if you only have Python 3 installed. Python 3.6 greetings.py, what do you think is going to happen when I run this program? What's your guess? Going to print out hello world, so we'll see hello world on the screen. Any other guesses? Won't do anything? Maybe we won't see anything on the screen yet? Yes, so that's a great question. The top half of my screen is my text editor. This will look very different for you. That top half of my screen there is my text editor. The bottom half, this is my terminal. So this is my terminal, this is my text editor. You can think of these as two separate windows on my computer. They are not, but they are effectively two separate windows on my computer. So when we run this, who thinks that this will print out hello world? We're going to see hello world printed out. All right, who thinks we're going to see nothing printed out on the screen? Okay, who thinks we're going to see an error printed out? Okay. So we see nothing printed out. So the reason we see nothing printed out is kind of a technical one, technicality here. If we type hello world over here, what are we going to see? Hello world. We just did this a little earlier. If you type hello world here, this string, we see hello world. The reason we see hello world printed out is we're at the REPL. The REPL reads what we type, it executes what we type, and then it prints out what we type, and then it loops. In our Python program, we didn't ask it to print. Yeah, question?
Is REPL the same as idle?
Yeah, so idle is a Python, it's a program that has a Python REPL inside it. So if you're using idle, idle is, it's really common to use on Windows because it comes bundled with it, and the Windows command line is a little bit less common to use than the Linux or Mac command line. But yeah, idle is essentially equivalent to the Python REPL. Other questions? So read, execute, print, and then it loops. Our Python program, it is not reading, executing, printing, and looping. It is reading and executing, and that's it. So it's executing this, it sees the string, it doesn't know what to do with it. If we want this string to print out, we've got to say print. So I'm typing print, typing an open parenthesis, sticking the string inside it, and a closed parenthesis. This is a function. It is a print function that is built into Python. So the print function is built into Python. You can call it from anywhere you like. When we run our code now, it prints out hello world. All right, at this point, I'm going to pass it back to you. We are at Your Turn Scripts on the website under Introduction. So you're going to make your first Python programs here. We've got 3 exercises. And actually, this first one you're welcome to do as well, this greetings.py one. Make a hello world program. The hello world program is kind of the traditional first program in programming, so feel free to make your own hello world program here. If you get through all 3 of those exercises, put up a yellow sticky. If you need any help or have any questions at all, put up a red sticky, and I'll come by and help out, or a TA will.
Everybody's got a text editor that they're comfortable with.
Oh yeah, if you do not have a text editor that you're comfortable with for writing code, or you don't know whether you do, please put up a red sticky, and a TA will come by and help. So the second exercise, meditative breathing guide, requires, it's a little bit of a leap that we have here. I meant to put up something on the website that is not up there. So there's an extra file that you did not download. It is called pause.py. It has 5 lines of code in it. One of them is blank. Import time, print hello there, time.sleep5, print goodbye. So the important part here is import time, time.sleep5. I would like everyone to write down these 5 lines of code. Put them in a file called pause.py. This file should help you make breathe.py. So if I run this code, it says hello there, it's waiting for 5 seconds here, and then it prints out goodbye. So pause.py, which is not on the website, but should be on the website, this is what it looks like. So I want you to write these 5 lines of code down and make that your pause.py. That should help you make that meditative breathing program. All right, I'm going to give you another couple minutes here. If you get done with all 3 of these exercises, put up a yellow sticky. Put up a red sticky if you need any help or have any questions. All right, we're actually going to solve this breathe.py one together here, because it's kind of a tricky one. So breathe.py, this is supposed to help you breathe 6.5 breaths every minute. It's supposed to print out breathe in, wait for some amount of time, and then say breathe out, and then repeat. It should do this for 2 minutes. So I'm going to copy this code here and make a file breathe.py. Oops, I didn't copy the right thing. This is just clipboard roulette. All right, so import time, hello there, sleeps for 5 seconds, and then prints out goodbye. This is not breathe.py. We want to sleep for some amount of time and then do that over and over for 2 minutes. Did anyone figure out how many seconds you need to sleep for? 5? So let's see, seconds, total seconds equals 60 times 2. That should be 120. Taking that and dividing by 6.5, I think. Let's do this in the Python repo real quick. Divide that by 6.5, we get 18. That doesn't make sense. I'm supposed to divide 60 by 6.5. So 9.23, does that make sense? Sleeping for that long? Yeah. So, all right, every 9.23 seconds. So we'll say, both breathing in and breathing out. That's a good point. All right, so let's say half breath time. Half breathe time? I don't know how to spell things. 60 divided by 6.5 divided by 2, is that right? All right, so half breath time. Oh yeah, should it be in parentheses? I don't know, let's see. Let's try this out. So we're going to go back to the Python repo here real quick. So it was, what, 9.23? Okay. So it actually seems to work without parentheses. Let's add those parentheses and see if it still works. Still works. So it actually works either way. I do think the parentheses make it more clear. So let's add those. In fact, we could. That's how I'd write it in math. All right, so we've got a half breath time. Let's type breathe in. And then sleep for this amount of time. How could I sleep for that amount of time? What could I type here? Time.sleep, and then what? Parentheses, half breath time. So I can use variables just like I can use numbers. All right, so breathe in, breathe out. Let's see, oops. Let's see if this works. We're running the wrong program. Breathe in, breathe out. All right, let's do that again. And how many times do we need to do this? 20? 13? I don't know who to trust here. So we've got, I'm going to make this a little bigger. Yeah, we haven't learned about loops yet. So we got to copy paste. All right, 1, 2, 4, 5. We will learn about loops in a little bit here. 6. All right, I'm going to copy those 6. That's 12. How many is it supposed to be again? 13, all right. And then that should be 13. We're not going to wait 2 minutes. Well, I ran it, so I guess we have to wait 2 minutes. So if you're running a program and you want it to stop running, this is different on different computers. Usually you can type Control-C, and that ends the program. Or you can close the window, and if it doesn't close, you can restart your computer. All right, any questions so far? Oh yeah, answers. We want answers already. We're not even halfway through the tutorial. Yes, I think I'll email it to you probably. I don't have answers for these. That's why I struggled with this. I've never done this program before. So we need to write answers for these, and then we might email you answers, because I think I can email you even after the tutorial is over. If I don't email you answers, feel free to send me an email pestering me asking for answers. I will not be offended. I want you to send me an email asking for answers, please.
Would it be better to do the calculations and store them in variables instead of
Do the calculations.
so like, how many times should you breathe?
Oh, I see what you mean, like seconds in a minute equals 60, and times to breathe equals 6.5. Let me put those here. Yeah, we could do that. Right. So one of the benefits of this 60 might be obvious. The 6.5 is really not obvious unless we knew the problem, the exercise prompt. If someone's reading this code, this might be a little easier to figure out. These are sometimes called magic numbers, when you have code that just has numbers in there and you don't know what they do. Giving those numbers a name it's almost never a bad idea. In general, if something is important, it deserves a name. So yeah, I think this is probably a good step. Other questions? All right, I'm going to make a new program here. This one I'll actually change greetings.py and say, I'm going to make a variable. But this variable that I'm making, I'm going to set it not equal to a string, but to a function call. I'm going to call the input function. So I'm going to call the input function. I'm going to make an f string. and put that variable in that f string there. Oops. Who has used input before, or seen input in Python code? Okay, so some of you have gone through a Python tutorial. Python 3.6, greetings.py. All right. What's a good name? No one has a favorite name? You've never been asked this question? Tyler? All right. Great name. Hello there, Tyler. So our program, it sets a variable. When it is setting this variable, it's calling input, which waits for us to type something in. Waits for us, the user of this program, to type something in. We typed in Tyler, rather I typed in Tyler there, and then it used that variable that it said. So notice if I didn't put a space after that question mark, it also doesn't put a space after that question mark. So Python is picky about the way we handle our spaces. All right, let's make another program here. I'm going to make a program called add.py. If you didn't write this down, don't worry, it is on the website. So add.py, I'm going to take a number, I'm going to take two numbers, x, and we'll say, what's the first number you would like to add? And then we'll take y, and we'll say, what's the second number you would like to add? And then we're going to add these two together. How do we add two numbers together? Plus. It's scary when I get a silence for something like that. This is an interactive tutorial, by the way. So I'm going to print out the sum is sum. Sum is sum of, that's not right. What should this be here? Sum of x and y. So that's the variable name I made there. By the way, making variables with really long names is not a bad idea. You can always shorten variable names later. It's difficult sometimes to figure out what your variable did if it's a really short name, though. So Python 3.6, add.py. All right, what's the first number you want to add? 23. All right. Somebody else now. I need a second number. 32. That's not right. What did it do? 2, 3, 3, 2. We got 2,332. What's going on here? Yeah, so when we take, we've used plus on two different things so far. Here, I'm going to jump back to here. I'll open up Python down here. So if we've got x equals 23, y equals 32, x plus y is 55. If we have x equals the string 23, y equals the string 32, x plus y, this is concatenating these strings. It doesn't care that they're numbers. It's concatenating these two strings. We get 2332. So these things here, this x and this y, these are strings. Every time you get anything from input, you get strings back. It doesn't know anything except for strings. Python knows nothing about input except for strings. So the types of these things, the type of 3 is int, the type of this string 3 is stir. You will not use type in your own code, but type is sometimes handy when you're playing around at the REPL and you want to figure out what the type of something is. If I had typed in print type x up here, and I ran our code, prints out stir. This is a string that we are working with. All right, so if we wanted to convert these things to numbers, we could use int, or we could use float. I'm going to use float. Actually, I'll use int for now, because we've been working with integers. 23, 32. What should this be? All right, sum is 55, so this is correct. Yeah, let's talk about that. So give me a number that is not an integer. 2.5 and 3.6. What should this give me? 6.1? That gave me an error. I think this is the first error we've seen. When you see an error in Python, or when you see a traceback, which is the type of error when Python blows up and your program doesn't do something wrong necessarily, it's actually just blowing up entirely. The last line we see on this traceback here is value error, invalid literal for int with base 10, 2.5. We tend to read these things from the bottom up. So the very last line tells us the type of the error, which is value error. Sometimes that's useful, sometimes that's confusing. Usually the thing after it is confusing. Sometimes it's actually useful information, a lot of times it's something that doesn't make much sense. This time it's kind of helpful. Invalid literal for int with base 10, 2.5. So 2.5 is not an integer, and we're trying to make it into an integer. That's what it's trying to say there. Then we can read up further and see what line of code this is on. We're going to jump over to this line of code though, and we're going to use float. So integers are just like integers in math. They don't have a decimal point. Floating point numbers do have a decimal point, or rather they can have a decimal point. So here if I do, what did we have, 2.5 and 3.6? This gives me 6.1. So float allows me to work with numbers with a decimal point, int does not. So I'm going to make this float. Now if I did the same thing as before, what was it, 23 and 32, we get 55.0. So floating point numbers, even when they're integers, they still have that 0.0 in them. So they've still got a decimal place even when they don't necessarily need it. All right, I'm going to push it back to you at this point. Yep.
So like, were you putting the input against equals input? Did you say float input? Because you know it's going to be a number.
Could I do that up here, like float like this?
Yeah.
Let's try it out. So the question here is, are we allowed to take functions and put one function right inside of another function at once? Let's see. Float of input of this string here. 2.5, 3.6. Yeah, that works. So we could do that right away. We can stick function calls inside of other function calls. All right, so in the exercises, we are in introduction, your turn input. If you get through all 4 of these exercises, put up a yellow sticky. If you already have yellow stickies up, yeah, take those down. So if you get through all 4 of these, put up a yellow sticky. I think we have a break coming up here at 10:15. We're going to try to do the break right at 10:15 because we did the break, or I did another tutorial yesterday. We did the break late and nobody got food because it was all eaten. And we need food because we've been working hard. So I'm going to try to take the break on time. Probably right after the exercises, we'll take a break. If you have any questions at all, whether now or during the break, put up a red sticky. I'm happy to help, and so are the TAs. there is food and there are beverages in the hallway. So if you're in the middle of something, I'd encourage you maybe in the middle of your exercises to force yourself to take a mental break. Not after the fourth one, maybe after the second or the third exercise, or after this first one here. Go out into the hall, grab some food, get something to drink. We will reconvene at, let's say 10:25, because we're taking this break a little bit early here. So be back in the room at 10:25 if you can. Go use the restroom, go get some food, go take a drink. So I'm going to give you about 15 minutes here for the break. If you have any questions at all during the break, feel free to ask me or a TA. Happy to help during the break. All right, I'm going to give you a few more minutes to work through exercises here. So I assume most of you were actually taking a break. All right, does anyone particularly want to solve one of these four together? Who would like to solve one of these together? All right, who would like to move on and get some more material done? Okay, we're probably going to do that for this particular section here. We may solve some of these together as we go. There's always a balance between solving exercises together and getting through more curriculum in 3 hours of time. If this was a 20-hour class, which is usually how I do Python classes, I actually teach Python for a living, by the way. I don't just do weekly Python chats online. Usually I do 20-hour classes. 20 hours and 3 hours are very different, especially when I don't get to meet you beforehand and make sure we're on the same page and have everything set up. All right, so programmers tend to ask a lot of yes or no questions. We tend to ask yes or no questions in order to know whether or not we should do something oftentimes. We branch our code. If something is true, do one thing, otherwise do something else. So to ask questions, we have to have conditions and conditionals. 0 equals 1. In math, is that true or false? That's false. In Python, this is not valid. We are assigning 0 to 1 here, and the reason for that is x equals 1, that assigns x to 1. 0 equals 1, we are not allowed to do. To ask if two things are equal, we say equals equals. So 0 equals 1, this is asking the question, is 0 equal to 1? That is false. 0 equals 0, true or false? True. All right, not equals. This is a little weird in Python. We do not have an equivalent of equal sign with a slash in it. Instead, we have exclamation mark equals. 0 does not equal 1. True or false? True. 0 is not equal to 1. All right, what about this one? What is that asking? Yeah, this is true. 1 is greater than 0. 1 is, in fact, greater than 0. So greater than or equal to, a little bit weird. We type greater than sign, equal sign. Greater than or equal to 3, that is false. 2 is not greater than or equal to 3. All right, -1 less than 0. Notice I can type this without spaces, with lots of spaces. Any of these work. True or false? True. And I can also do this with different numbers, 0.5 and 1. True or false? True.
Spacing that you just highlighted there, would that also, wouldn't that really work for
It would work in a script, actually, yeah. So Python, you may hear that Python is a white space specific language. Python actually mostly doesn't care about white space. The places where Python cares about white space is if you have a line break that goes to the next line. Unless you have parentheses or curly braces or square brackets or something open, then Python knows there's more to come. And so you can wrap your lines of code, but you've got to have those open parentheses. The other place Python cares about white space that we haven't seen yet is indentation. So we're going to see if statements in a little bit. Python cares about indentation. You'll sometimes hear programmers complain about, Python cares about indentation. I don't like that. I like my languages to not care about indentation. That is the place where Python cares about white space. Indentation and line breaks. Everything else, couldn't care less. Other questions? A is less than B. What do you think? False? True? Don't know, so maybe it's going to give an error. So who thinks it's going to be false? Who thinks it's going to be true? Who thinks it's going to give us an error? Who thinks it's going to give us something else? So a little bit strangely, Python says true. It knows that A comes before B. So A equals A. What do you think? True or false? This is true. Yep.
The character comparison is based on the ASCII code.
Yeah, so what is going on here? So A, lowercase a equals uppercase A. What do you think for this one? Who thinks true? Who thinks this might be true? Who thinks false? Who thinks error? Okay, no errors at this point. It is false. Lowercase a is not equal to capital A. So yeah, what is going on here? Let's try this with something else. Apple is less than animal. Can we even ask that? All right, who thinks this is true? All right, who thinks it's false? So this is false. Why is it false? Alphabetical. So if you were looking up apple in the dictionary, it comes before animal? No, it comes after animal. L-M-N-O-P. It comes after animal, which is why this is false. So apple comes after animal in the dictionary. So apple is not less than animal. Apple is greater than animal. What about this one? How do dictionaries work normally? Do the lowercase or the uppercase come first? Does it matter? I think in dictionaries the lowercase come first when you've got like lowercase a, capital A, but it might depend on the dictionary. Python works different. Python says this is true. The capital letters come before the lowercase letters. So I heard a question earlier, is this ASCII? So if you've seen an ASCII table before, all of the letters in Python have numbers associated with them. Capital A is 65, lowercase a is 97. I don't know any of the other letters because you can figure them out from those. You do not need to know any of, numbers. I don't know any of the other numbers associated with these letters. You don't need to know any of that though, because typically you're not asking if a lowercase word and an uppercase word are less than or equal to each other. All right, any questions about this? Yeah?
The character string comparison is supposed to compare the first character first, is that right? If they are the same, then compare the second.
Yeah, so there is an algorithm going on here. It's kind of like when you're in a dictionary. If you're asking, are they less than or are they greater than, it's looking at the first character. If they're equal, then it doesn't know how to answer the question yet. If they are not equal, it knows how to answer the question. If they're equal, it has to go to the next letter. Ask if they're less than or equal to. If those are equal, it goes to the next one. And so yeah, it's going in order, kind of the same way you would do this if you were looking up things in a dictionary. So this is called, sometimes called ASCII-betical ordering, kind of like alphabetical ordering. In general, this notion is called lexicographical comparisons. You do not need to know that word, and I don't even think it's on the website, and I'm probably never going to say it again. Except for the next time I teach this, I guess. H in hello. That is true. So we can ask Python if H is in this hello here. What about LO in hello? What do you think? That is true. So we can ask not just as a letter in a word if a substring is in a larger string. X in hello, what do you think? Not in hello. So what about HL in hello? Who thinks true? Who thinks false? So it is actually false here. It's false not because H and L are in hello, but because it's looking if H is followed by an L in hello. So it's checking if this little substring is exactly in there in consecutive order here. All right, if we want to know if H is not in hello, we can say not in. H not in hello, it's the opposite of that question there. So these conditions, in, not in, less than, greater than, equals, not equal to, these aren't very useful unless we have some way to use these conditions. So we're going to make an if statement. This is the first time I have made a multi-line statement. So watch what happens here. I'm typing year equals 1999. If year equals 1999, colon. When I hit enter, I see 3 dots. What do those 3 dots mean? What do you think? To be continued. Yeah, Python is waiting for us to type more. So we see an ellipsis there. I have to indent my code. So I just typed space 4 times. I could have typed tab too. We have to indent our code somehow though. And now I can type more code. So we have an if statement, we have print indented under this if statement here. Now notice it has to be indented. If I hit enter again, I see 3 more dots. Why is Python still waiting? Yeah, we might have more to type, so we might want to indent and type something else. We can, we don't have to. If I type enter again, it's still waiting. If I want it to be done at this point, because I'm at the REPL, I can hit enter another time, and Python executes our code. All right, so this is an if statement. I'm going to show you the other part of an if statement real quick here. We can say if year equals 1999, just like we did before. So I'm in the REPL here. If I hit up arrow, this is a shortcut for me to go to previous lines I've typed. Notice I just typed else. If something, a line of code, I could type as many lines as I wanted. Else, this is not indented though. This is all the way lined up where my if is. Another colon. What does that colon mean? What do you think? Waiting for more stuff under it? Yeah, so that colon means we expect an indented block of code. We've got some code underneath this little statement here. So else here, when you see that colon, it means we have to indent that next line of code. At least one line of code has to be indented under that else. So we've got if, print something else, print something else, print something different. What is it going to print here? Boring year? Yeah. So we did the else this time. We would have done the if that year was still 1999. All right, I'm going to push it back to you here. It's now your turn to work through conditional exercises. So we're now in the conditional section. If you have any questions at all, or if you want to walk through something with a TA, or if you just want to talk about what we just did and ask questions about it, feel free to put up a red sticky, please. Happy to help. We have 4 TAs and me in the room, and we need something to do, so we are very happy to talk to you. Yeah, if you don't like the sticky system, use any other way of flagging us down. Just kind of look in our direction and we'll run over. So I'm going to give you much longer on this particular exercise section. Probably about 10 more minutes. If you get through all of these, put up that yellow sticky. I don't expect you to get through all of them, though. There's quite a few of the exercise in this section. If you have any questions at all, put up a red sticky. All right, we are also not going to solve one of these together. If you have questions about any of these exercises, feel free to stick around afterwards and ask a TA or email me afterwards. And actually, I'll announce it at this point before I forget. So at the end, I would like to talk, well, at the end, who would like me to kind of take a little chunk out of the curriculum and instead talk about what PyCon is like and what you might want to do at your first PyCon here, like 10 minutes or so? Who would like to do that? Okay, who would like to instead do a little bit more curriculum? Okay, so we're a little bit torn on this. Probably I will try to run it to about 10 minutes towards the end and then talk a little bit about not what PyCon is like, but what things you might want to keep in mind at your first PyCon here in the last 5 or 10 minutes. Also, afterwards, there is lunch at I think 12:20, right after this ends. If you would like, we can all do lunch together. I think I don't know if all of our TAs are available for lunch, but I know at least a few of us are. And so we're all going to go to lunchroom. If you want to sit at the round tables together, we can split up into about 4 tables and all do lunch together. If you don't want to join us for lunch, feel free to go to another table, but we're all going to go to the lunchroom at the same time. So we can all do lunch as a group and talk about, feel free to ask us questions about PyCon. Melanie and Charlie, this is their first PyCon as well. So some of our TAs, this is their first PyCon. You are definitely not alone here if this is your first PyCon, because many of the people at the conference, I don't know how many people, but a large number of the people you will meet here, this is their first PyCon. Whether they're experienced programmers or new programmers, for a lot of us, this is our first PyCon. All right, let's talk about our first data structure. What are some feelings you have about PyCon? Anyone else want to shout something out? Charlie started it. Nervous? That's a good one. Anyone afraid? What? How do I spell that? Syntax. All right, jet lagged. Oh, that's a good one. All right, we're going to leave it there. So we've got a list of PyCon feelings. This is a list. So I typed an open square bracket, and then I put strings inside of this. Now, feelings are not the only thing you can store in lists. Strings are not the only thing you can store in lists. You can store numbers in them. You can store Booleans in them. You can store any type of thing that is any type of thing in a list in Python. So this things here, this has 3 things in it. PyCon feelings has more than 3 things in it. We can also put lists inside of other lists. So I said you can put anything inside of lists. You can even put lists inside of lists. So more things has 2 things inside it. It has one list and another list. The type of these, by the way, the type of things, what do you think that might be? String? It's a list. Yeah, the type of PyCon feelings, also a list. So lists do not have, they don't care what type of thing you put in them. You can put anything inside a list in Python. Lists are ordered, and you can loop over lists. We're going to go over loops in a little bit here, but first we're going to jump into exercises. Before I do that, 5 in things. What is this going to tell me? This is true. So things up there, somewhere up there, we define things. It had 5 inside it. So 5 is in things. False in things. What is that going to tell me? Yeah, true is in things. False is not in things. What about hello in things? That's true. What about HE in things? What do you think? Who thinks it's going to be false? Who thinks it's going to be true? So it's false. So this question we're asking, is this contained in this other thing? It's a shallow comparison. It's checking is exactly HELLO, that string inside this. It doesn't do a substring check inside of that, so it's not a level down. Any questions about lists? All right, we're going to do lists a little bit more right after exercises, but we're going to take a little exercise break for lists. So we are at your turn lists under the lists section. And if you didn't write those feelings or things down, they are on the website. Well, not the same feelings, but some list of them. And I'm going to give you probably about 10 minutes on these. If you have any questions at all, put up a red sticky. Questions about anything, happy to help. All right, who would like to solve one of these ones together? Who'd like to solve one of these together, these lists here? Okay. Which one do you want to do? Guest list, virtual friend, lazy chef sandwich generator, acquiring orange ink, interactive rock, paper, scissors, or magic 8-ball. I'm hoping no one got to the end of these because you worked very quickly if you did. I think you program faster than I do if you got to the end. Who would like to solve guest list together, this first one? Okay, who would like to solve virtual friend together, this second one? Okay, who would like to solve lazy chef sandwich generator together, third one? Okay, Charlie, why are you voting? Who would like to solve acquiring orange ink together? Okay, we're going to do the second one, virtual friend. Like I said, I haven't solved these myself yet, so we're probably going to make some mistakes along the way. Create a program, myfriend.py, that does the following. It asks you how you are and compares that input that you typed in to a list of good emotions and a list of bad emotions, and prints out an appropriate response depending on which list the input is in. If it's a good one, if it's a bad one. And it chooses a random response if the, if the input isn't in either list, it says that it doesn't know what that is like. And it chooses a random response if the input "how are you" is received with any capitalization. A random response meaning some emotion, I think. Or it could just be a random number that's printed out, but I don't think that's what that's meant. So how do we ask the user, how are you? What should we do? Input? Make it a variable, okay. What should we call this variable? User input, query? Naming things is hard. Naming things is one of the hardest parts about programming. We could say user feeling. That's not a good variable name either. So input, what are we going to ask here? I guess, how are you? And then we need lists. We'll say good emotions, this is a list, and bad emotions. So we've got square brackets, we're going to stick things inside them. These things are going to be strings. So quote, quote, I'm going to make a non-empty emotion. So what's a good emotion? Good, great, happy, awesome. All right, we're going to leave it there. Bad emotions. Sad, angry, tired, upset. We're going to leave it there. We could do bad emotions all day. So good emotions, bad emotions. Do we need any other lists here? I don't think so. So we get user feelings, then what are we supposed to do? We compare them to the list of good emotions. Let's do that first. How can we compare the user feeling to the list of good emotions? If user feeling in good emotions, then what? What do we print? What would be an appropriate response? I'm glad you're feeling, and then say what they were feeling. Okay. I'm glad you're fleeing. All right. Oops. Okay, let's do another if statement. If user feeling in bad emotions, then what do we say? I'm sorry. We could just say I'm sorry. That's maybe a little rude. All right, my editor thinks this is invalid syntax because it's thinking I'm typing in Python 2. This is a problem sometimes. You're probably going to have to configure your text editor occasionally if it knows about Python things. So we've got good emotions, we've got bad emotions. What else are we going to do here? How do we know that? Yeah, so would we print out here? Let's actually just try what we have here right now. So typically when you're writing code, you don't want to write your whole program at once because it's probably buggy. Because when you write code, it's broken. No one writes code correctly the first time. Now, I may have written something correctly here. My code is probably syntactically valid because I cheat. My text editor yells at me when my code doesn't, or when it has invalid syntax. So I'm cheating here, whereas your text editor might not be telling you that. So I think it's syntactically valid. I don't know if it works. All right, how are you feeling? Tired. I'm sorry you're feeling tired. So that seems to work. Let's say we're feeling good. I'm glad you're feeling good. Okay. What's something we don't understand? Hungry. Doesn't say anything. Okay, so how can we get it to say something? Else? Then what? I'm going to type this. Don't know what that's like. All right, so we'll say hungry. Type good. Oh, that's odd. I'm glad you're feeling good. I truly don't know what that is like. So we've got a problem with our program. Anytime we type a good emotion, it says, I'm glad you're feeling that way. I truly don't know what that's like. This is a sad robot we've made here. We're not trying to make a sad robot. We're trying to make a virtual friend. So why did it do this? Yeah, I have one if here that executes, and then we go to this if. Elif. Okay, so we haven't talked about elif. We could do this. You can put if statements inside of if statements. So you can have indented code that has indented code inside it. So if else, do this whole set of things. If this is also not true, then we get down to here. So we're sticking if statements inside of if statements. So now, if you're feeling good, it does not end up getting down to here because we have this entire block of code inside of our else. So elif, how does elif work? Where would I put that? Here, elif, what would I do? User feeling, so I can copy this. And then do I need this if? Okay, so if this, elif this, else. So I didn't talk about elif. We can chain else and if like this using elif. So some programming languages call this else if. Some call it else if without an E. In Python, we call it elif. All right, I don't think that was the whole program. I'm going to leave the randomness part up to you, though. What? If you're sad with a capital S. We don't know what that feels like. Could we say what? Oh, in a dictionary? Yeah, so we both had different interpretations of your question, and we might both be wrong. During the next exercise break, feel free to ask individually. But yeah, this is what Kojo was talking about here. Hungry says, I truly don't know what that is feeling like. Dictionaries, I was thinking you meant dictionaries in Python, which is a type of data structure. We're not going to talk about those today, but I am going to mention those as one of the things that we're not talking about today at the end of class. I do have material on that is online. Any questions, any other questions? So we're going to talk a little bit more about lists here. Yep.
What's going to be more efficient, using if, elif, or using constructing that before we have the nested if and else?
Yeah, so efficiency in general, this is a cop-out question or a cop-out answer, but in general in Python, we typically don't care about efficiency, mostly because you can often optimize for efficiency later. Usually your bottleneck is developer time. Sometimes your bottleneck ends up being process time, but often it's difficult to guess where the bottleneck is. If something saves you a millisecond, but something else is taking a second, that millisecond really doesn't matter. In terms of the actual answer to your question, the answer is I don't know. I think the elif else would probably be faster simply because it's a special syntax. This might be just as fast though. It's really a matter of which machine code are they generating because it parses this very quickly. And I would guess it's generating very similar low-level machine code, but I don't know. Other questions?
Does the Python support case?
Switch case statements, yeah. So if you've done programming in other languages before, you've seen switch case statements maybe. Python does not have them. Doesn't have them, so we have if, elif, else. We also have dictionaries, which are used often for mimicking switch case statements. You can often use key value pairs in a dictionary for making a switch case statement or something like it. Other questions? Yep.
How many else's can you do one step after another? There's no switch. Is there a limit?
Yeah, can you do if, elif, 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 elif? Yeah, you can do as many elifs as you want. So you can do 0 elifs, because we already saw if and else. You can do as many elifs as you want. You, in fact, don't even need an else there. But yeah, there's no limit to those. You do have to have an if. You always need an if for elif and else, though. Other questions? Yes. So, yeah, and in fact, this might have been, I don't know if this is what you were talking about earlier. We could say if user feeling, not in good emotions, and we didn't talk about this. In Python, we could say and user feeling not in bad emotions. So if we wanted to be a little bit more explicit there and say if this, elif it's not in either of them, but this is already true at this point. This is already true because we know it wasn't in either of those. So we could just say else. But yeah, we can have as many elifs as we want. Do we need to have one? Can we just go like this? Yeah, we can. Yeah, so we could say this and say hungry, and it just says nothing at all. No response, it walks away. That's a rude friend. All right, let's learn a little bit more about lists. So we have a list here. If we want to get the first thing from numbers, we can use a square bracket, 0 square bracket. So in Python, as in many programming languages, we start counting at 0. We do not start counting at 1, which is a little bit odd, but that is the way things work in the world of programming typically. Now notice, I assign this to a variable. If I just type this list here, it gives me a list back. Variables are not king when it comes to Python. Variables, the most important thing in Python is lists. Or sorry, not lists. The most important thing in Python is objects. Objects are the important thing. Variables just point to objects. They're just a name for an object. So this list here, I could use this 0 to get the first thing from it. Now that's a silly thing to do because we made a whole list just to get the 0th item and then throw the list out, but we could do that. So we've got numbers here. We can grab the first thing from it. We can grab the second thing from it. We can also do this. Any guess what this is going to give me? 1 and 2, 3, 1, 2, 3. Okay, so who thinks it's going to give us 1 and 2? Who thinks it's going to give us 1, 2, 3? Who thinks it's going to give us 3? Who thinks it's going to give us something else? Okay. Gives us 1 and 2. So what is going on here with this colon? It is a slice syntax. So this is valid. It goes from 0 to just before 2. So it doesn't give us 1, 2, 3 because it is stopping just before 2. So this 2 here, it is not the number that we get, because if I went 1, 2, it only gives us 2. It is start and it is stop, just like you probably intuitively might have thought it was doing, but it's stopping just before that second number. So if we wanted everything in this list, we could do 1, 0, 1, 2, 3. That would stop just before the end. We'd have to do 4, which is the number of things in this list.
What if you didn't have your number, what if you didn't put a 3 or 4 there, just 0 and the colon?
Oh, 0 colon? Yeah, no number here. Like this? What do you think will happen? Everything? Maybe an error? Same thing. So that actually works. What about this way? Colon 2. 1, 2. So it's starting at 0 by default. It's ending at the end by default. What if we just put colon? Does that work? Yep, 1, 2, 3, 4. So it gives us everything in that list. So this colon, things before it, things after are optional. There is more to this colon syntax. We're not going to go into that. I do want to show you real quick. If you want to get the last thing in a list, you can type -1. So we can index from the end. There is a lot more to list. You can get lengths on lists. You can slice in other ways. The documentation for Python is pretty good when it comes to showing how things work. It is not very good at being a tutorial. It's better at a reference guide. There is a tutorial in Python in the documentation. The tutorial is okay. It falls over when it comes to certain types of explanations, though. Get used to using the Python reference, though. Also, get used to going to Google and typing in Python space something and hoping that something useful will come up. Usually you end up on Stack Overflow, often 3 people arguing over something, and one of them is the right answer, and it's up to you to figure out which one it is. Sometimes it is a link to the part of the documentation you were looking for that you didn't find when you went to search for it because it was using a different word. The Python documentation is not the most searchable thing. This is a known problem. Just because it's a known problem doesn't mean it's a fixed problem, though. It takes someone to fix it, and it takes time to fix that problem. Yeah. Yes. Yeah, we will talk about the sprints afterwards. So at the end, we will talk a little bit more about other things that can go on at PyCon. I'm going to mention real quick here, if you've got a list of things, actually let's look at do we have emotions? No, PyCon feelings. So I could add something to the end of this list by using append. So we use append to add something to the end. What's another emotion that we missed out on here? Apathetic. So we can add something to the end. We can also remove a particular emotion. Maybe we no longer want to feel afraid, so we're going to remove afraid from there. That's how emotions work. You can just remove them and it works. So PyCon feelings here no longer has afraid within it. We removed that by its name. Now you can also remove things based on their position. I'm not going to go over that. Actually, I'm going to go over that, but first I want to show you how to remove something from the very end. So pop, this is the opposite of append. So pop is kind of a weird word. The reason we have the word pop is because some other programming languages have a push and a pop. You can push to the end of the list and pop from the end of the list. Python, we have append and pop. For some reason, they decided push was weird, and then they couldn't figure out a better word for pop, so they just decided to use pop. So the opposite of pop is append, and the opposite of append is pop. Yeah, let's see. So if we were to overwrite one, like saying PyCon, this first one, instead of hooray, maybe it's hurrah, that would change that item in the list. So we can actually use that 0 to change a particular one. You want to insert one without overwriting one, though. Okay. So if we insert it where? At the beginning? The middle, okay. Yeah, let's say insert. So we can use insert to insert maybe, I think it's after the third one. I don't remember the syntax for this. Maybe it's hooray, yippee, 3. That's not right. 3. Let's see where that put it. So let's see, 0, 1, 2, 3. Is it going to be before baffled or after? What do you think? Who thinks after baffled? Who thinks before baffled? All right, I'm going to guess before too, because it seems like that's the popular one. It is before baffled. So yeah, we can use insert. So in the documentation, it goes over insert, goes over pop, goes over append. It talks about a lot of these things that are in there. And in fact, you can remove from a particular part too. So we could say pop 3, and it pops off yippee, and it is no longer in there. So you can give pop a number as well. Yep, yeah, if you only do pop without any number in it, it would pop off jet lagged. Yep. All right, we have some exercises now. So we are under more lists. So it's your turn on more lists here. And we're running a little bit tight on time, so I'm going to give you a little bit less time for this one, I think. If you have any questions at all, put up a red sticky. We're happy to just talk through the problem with you if you want to brainstorm things together. Finish all of the exercises. Put up a yellow sticky. All right, so these exercises, there's quite a lot in these ones. I'm going to suggest that we skip solving these particular exercises together and move on to the next section so that we get a little bit more in, because I'd like to have a little bit of time at the end to talk about for a couple minutes what I'd recommend that you do in your first PyCon here. All right, so we have a list. We have a list called PyCon feelings. If I want to print out everything in this list, we could use a for loop. So we talked about for loops earlier. What were we talking about for loops for? Right, we needed to take 13 breaths, and we wanted a for loop for that instead of copy pasting a whole bunch of code. So for loops allow us to loop over a list of things, or loop over anything you can iterate over, which is kind of a tautology there. Anything you can loop over is something you can loop over. Lists are one of those things that we can loop over, though. So I could say for feeling in PyCon feelings. I am assigning a variable here. Every time we loop through PyCon feelings, we are getting a variable feeling that I can use. So this is going to print out how many things? printed out 6 things there. So all the things inside of our PyCon feelings list. So if you've done any other programming language before, you may have heard of for loops. Python does not have for loops. I just said Python has for loops. Python does not have for loops. Python has for in loops, which are different from what people call for loops in the C world, in the Java world, in the JavaScript world. These for in loops, we tend to call just for loops because it's the only thing that we have. It's the only thing that we know. So for in loops, if you wanted to look up how these work in other languages, you can search for each, all one word. If you find the for each article on Wikipedia, it talks about the whole notion of for each loops. We know them as for loops or for in loops. So for loops in Python, different from for loops in other programming languages. They allow us to loop over things without having to worry about indices. We just get the thing back when we loop over it. Question?
So let's say you wanted to loop over 5 iterations. Would you have to do a flat and then
Loop over only 5 of these things? Yeah, so if we wanted only 5 of these, there's a couple ways we could do this. So we haven't talked about while loops here. We could say I equals 0, while I is less than 5. Yeah, print PyCon feelings I plus equals 1, or I equals I plus 1. So this is a... Oh, that didn't work. Oh, yeah, you're right. It should be less than 5. So that didn't work because I typed the wrong logic. But it would have worked if I typed less than 5 instead, and you'll just have to believe me. While loops, though, you don't see while loops much in Python, and the reason for that is even though we only have these 4 in loops here, we can combine these with things like, for example, slices. What slice would I want to get the first 5 of these? 0 to 6? Let's see. 0 to 5? Ah, yeah, it's 0 to 5. There we go. And in fact, we could have even said just :5. There's no harm in being explicit there, though, with that 0. So there tend to be other constructs we can use for accomplishing the same type of task we might accomplish in other languages. There's slice syntax. There's also ranges, which we'll talk about in a minute here, actually. And there are other things that allow us to accomplish a similar task to what we might have done in other languages. So a couple things I want to mention before we move on. If you are not feeling particularly connected to your duck or your pear-shaped duck, there are more ducks in the duck bag. You can find Melanie or Charlie if you would like to trade your duck or exchange your duck for one of the ones that is in the duck bag in the next exercise break or right now. So feel free to get a different duck. These ducks are important because after you leave this room, I am not coming home with you. I'm not coming home with you. None of the TAs are. We're going to, be at PyCon, then we're going home. You are going to have your duck with you, though. Your duck is there for you to talk to when you are coding. Also, I think there's probably about a dozen of you who haven't asked questions yet, which means we should probably have a question about every 2 minutes from here on out. So I'm going to try to make more space for questions, and I'm going to ask you if you've asked questions already, I guess pause, put the brakes on, ask fewer questions, or rather, when I ask, are there any questions, pause an awkwardly long time, and if no one asks a question in 20 seconds, maybe get your question in. But if you haven't asked a question yet, try to ask those questions soon. And asking them aloud, asking them in your head doesn't count. If you do have extra questions, though, and I'm just not getting to them, please, during an exercise break, put up a red sticky. I'm happy to sit with you and talk about any questions that you might have. And afterwards, we can answer questions as well. Any questions at this point?
This site is going to stay up.
This site will stay up, yes. Other questions? That looked like you had a question. All right, yep.
Sorry, when you are running the while loop, do you need to change the counter value? For example, I equal
I do not, no. So we do not have for loops like that we do in other languages. In Python, we've got these for in loops. They automatically do that for us. Other question? No, we don't have switch statements. Yeah, so switch statements, the way we would use switch statements or something like switch statements is usually dictionaries. There is material on dictionaries, I think, and I might be lying about that. Let me make sure I'm not. Yes, there's material on dictionaries in the bonus section. There's material on dictionaries as well as command line arguments and functions, which are all questions that tend to be asked that we just don't have time to go into. But yeah, we don't have switch statements. Other questions? All right, well, feel free to spend this exercise break, not just working through exercises, but thinking up more questions. It is your turn now. We're going to work through loops. And then we are going to talk about, so there's a section on ranges. We're going to not do that yet. We're going to talk about files next. So we are working through loops exercises right now. If you have any questions while going through these exercises, please put up a red sticky. Or if you have extra questions I haven't gone through yet, put up a red sticky. And I'm going to give you just a few minutes on these ones. So I'm going to give you another minute here. If we're not going to work through these exercises together, so if you want to know whether one of your exercises works or you're struggling to figure one of them out, put up a red sticky. Love to help you talk through one of these exercises. All right. I actually think I have like cards that say my contact information if anyone doesn't have it. I'm going to try to remember to put those out at the end. I guess we're all going to potentially go to lunch together anyways afterwards, so don't leave immediately if you want to do lunch together. So we're going to not solve exercises here. Feel free to ask me questions about them afterwards. We're going to move on to the next section. So we just talked about loops. We are going to now talk about files. So I'm going to say declaration file equals, and I'm going to open up declaration of independence.txt. I actually haven't downloaded this file, so I'm going to do that first. All right, that did not give me an error, which means it opened the file up correctly. Once I have this file open, I can say declaration file dot read. This is a method. We have not talked about methods yet. Strings have methods, lists have methods. The pop thing on string or on list, that is a method. Append is a method. Anytime you see something dot something and you've got parentheses being done after that, that is a function that is being called. That function lives on that object. A function that lives on an object is a method. So this declaration file, it has a read method. So I'm saying declaration file.read. It's going to give me a string. So I'm going to say declaration text equals this thing here. This is a very long string. If I print it out, you'll notice there's a \n at the end of that string. What is \n? Anyone know? Yeah, new line. So this has new lines within it. So when I print it, it's actually printing out those new line characters as actual new lines there. So I opened this file like this, and I read the contents of this file. I'm going to type that again. I'm going to type that again in a program. And actually, I'm going to copy paste in a program. We're going to walk through what it does. So this program is called filestats.py. It asks the user for a file name as input. What is the name of the file you would like to know about? And then it has a function. We have not talked about functions. This is a function. You define a function like this, def, the name of the function. This one takes an argument, and then we are calling the function down here. Now, we don't actually need this function. We could do this outside of a function. Either way works. I'll leave this function in just so you can see a function being used there. We are opening up whatever file name was given to us, and then we are reading that file object, getting the contents of that text into a string that's in this contents variable, and then notice this, we are closing this file. Why do we close files? What's the point? Could we not close the file? Maybe we don't save it? Yeah. You can't open it again, maybe? Yeah, so in this case, we're reading the file, so there's not actually anything to save here. Maybe when we were writing a file, there might be an issue with saving, though, if we don't close. But if we have a file open on some operating systems, on some file systems, namely on Windows, if you open a file in one process, you try to open the same file somewhere else, it doesn't let you. It says it's locked. On a lot of operating systems, it doesn't do that. However, it is always a good idea to close your files. Always a good idea to close your files when you're done with them. Now, this is actually a problem, because if there was an error here, this line would never get called. So in what we normally do in Python, we have a special syntax for opening files. With open the file name as stat file, then we indent this, and then we can read the file. When we leave this little with block here, it automatically closes the file for us. So this might seem a little weird. We haven't seen with yet, but I want you to do this every time you open a file in Python. I would prefer you to use this with block. If you can't figure that out, feel free to do it the other way. Both are listed on the website, but this with block here is the preferable way in Python to open files because it automatically closes the file for us. Yeah, so I don't, that's the case for the first one. If you scroll down a little bit, we have with indented. So this way it is not indented. That's a good point. This read here is not indented. The reason read isn't indented here is we're not in a block. The with thing here, how do I know that I need to indent? Yeah, this colon here. So I've got with open file name. I've opened the file name as stat file. Whenever you see a colon, the next line has to be indented because there's a block of code. And so contents equals stat file.read, this has to be indented because if it wasn't, we'd have a problem. But if we did something in here, if something was a valid thing to do, it would close our file. We try to read the file, it's going to be closed, and that's not good. So we have to put that read under that with. Any questions? Yeah, so the close here, we are not calling close. We're not calling close. The reason we're not calling close is with does it automatically. And so the place that it calls close is when it goes back out, when it outdents. So we say with, we've got an indented thing. If we printed out hello, the file is still open here. Once we're on this line, because it's not indented, it closes the file just before it executes this. So this with here, it allows us to say, look, we don't want to worry about closing files. We know we have to do it, but it's a chore. Could you just please do it for me, Python? And Python does it for us. That's the useful part of this with block here. This is called a context manager, by the way. If you wanted to look up what this thing is, this with block, a context manager, if you search for with block, you'll find the same thing though. You mostly don't need to know how this works. Know that this is something that you do when you open a file. It can also be useful when working with databases and that kind of thing. Anytime there's a cleanup step, this could be handy.
The nice thing about that with blocking context management is, again, it reduces the number of things that can go wrong. So there's a situation where you might open a file and then forget to close it. You forget to do file.close, or you forget to do database.close. So using a context manager just takes care of that for you. It's almost like having another little person there who knows, okay, you open the door, walk through it. You should close the door after you walk through it, but maybe you forget to close the door. So that with block there just handles that stuff for you.
Yeah, it avoids errors in your program due to the fact that you haven't closed files. So we've got a sentence. If I call split on this string, I get a list. This list has 3 words in it. This list has 3 strings inside it. It split this string based on spaces. I could have split it based on commas. Gives me 1 string because there's no commas in there. Could have split it based on something else, but I'm splitting it by the default, which is any white space. So this here gives me words. Now, something we haven't talked about here. If I have these words, in other programming languages, for anyone who's used another programming language before, how would I get the length of this list? Yeah, words.length. This is what you'd see in other programming languages. This does not work in Python. Yeah, there is no words.length. Instead, we say len words. We pass words to the len function, which is a little weird, but that's the way we do it in Python. So len is a general notion. It's almost like an operator, like that plus sign. It's not. It is a function, but we pass words to len and say, len, please tell us what is the length of this thing that we're working with, which happens to be a list. Len, we can pass a string to it too, so we could take our sentence. It says it's 16 because there are 16 letters in that sentence. So length is a general notion, which is why we have this len function. Yep.
16 letters or 16 characters, including space?
Yeah, so this is 16 characters, including those spaces. Yeah, other questions? Yep.
So is that function, so the content will declare as a string, right?
Yes, contents here, it becomes a string because that's what read gives us. It's a stat file.read. Stat file is a file object thing. I don't know what the type of this thing actually is. We could look it up. The type is probably something a little bit weird. This with open as stat file, this creates that stat file. And then we get a string out of it. And then split here is working with a string. It gives us a list, and then we were asking that list for its length. So there's a lot going on in 3 lines of code here. Yep. Yes, so contents is a string. Split is a method on strings, which gives us a list. We have that list. Lists have a length. We are getting that length. If we wanted to also say character count equals len of, what would we get the length of for the character count? Yeah, just contents, because that's a string. So we get the number of characters in there and print that out as well. Other questions?
So it read the entire file as one giant string, right? So if you wanted to be really specific, you could go in and take which lines.
Yeah, so if you can actually read line by line. So we learned about for loops. You can say for line in stat file and read line by line. Yeah, if you want to loop over it line by line, you can do that as well. And that's useful. If you've got a 10 gigabyte file, you probably don't want to read that into your system memory. All right, so we're pretty close to time here. We're not going to get to file exercises. You can do these on your own. I do want to show real quick if we did want to write a file.
I assume with the open method, you have to do all the work in the block before you exit out. Or
Yeah, exactly. Yep, you have to do everything you want to do with that file before you exit that block. So we can use write to write to this file. Notice I'm putting a new line character at the end. Print automatically prints out a new line character. Write does not. So if I look at the contents of this test.txt, I see hello world in there. So we can write to files by making mode wt, write text mode. Mode is automatically RT, which is read text mode. You can look this up on the website. The documentation also has a lot more on files. There's also an append mode, which you're going to need for the exercises. And there are a couple other hints in the exercises as well. So we are not going to have time to go through these file exercises here. I do want to wrap up real quick with some kind of closing announcements or mentions about PyCon. Anyone who didn't get in a question, do you have a question by any chance at this point? If you don't, we can talk about stuff at lunch. Yeah, this website will stay up indefinitely. It will be up for at least a year. Yeah, at least a year. If it, no promises it's up more than a year, but it'll be up at least a year. So things we did not cover. We didn't cover functions. We didn't cover classes. We didn't talk about modules. We did not talk about other types of data structures like dictionaries, which are pretty handy in Python, which you can use for switch statements and other types of stuff. We didn't talk about third-party libraries. The Python world, there's a whole ecosystem of all sorts of libraries you can use, NumPy, Django, SciPy, all sorts of things that help you write your code, because reinventing the wheel is a bad idea unless you need to make a really particularly different wheel. The standard library is full of tons of built-in stuff too. So these third-party libraries are code someone else has written floating out there that you can use. There are standard libraries built straight into Python. You don't have to do anything to get those installed. They're built right into Python. For example, import random, which you saw, that is built into Python. There's lots of things built into Python. There's even CSV parsers and all sorts of things for doing networking built into Python. You can ask for help on mailing lists, chat channels. Feel free to email me if you have questions. Okay, so during PyCon, probably all of you are thinking you're going to go to the talks. You're going to go to the talks during PyCon. There are 5 tracks for talks. So you're going to miss out on, 80% of PyCon at any one time? I want to let you know that you're actually going to miss out on more of PyCon at any one time, not just 80%. So 4 divided by 5, that is 0.8, 80%. There are actually 9 open spaces. Open spaces they're not talks, they are self-assembling. So open spaces are in these rooms in here, I believe, and where the tutorials are. They are places, there's an open spaces board that is next to the registration desk that just appeared there earlier today. And you can go to that board, which is mostly empty right now, put up an index card that says something on it. For example, people with colored hair. People hopefully will show up to that open space who want to talk about coloring their hair. Knitting, you can have a knitting open space. You can have a board games open space. You can have an open space for people who are interested in big data. You can have an open space for people who are interested in getting into freelance web development. There's open spaces for anything. So there's, for example, an open space last year, there's a sticker exchange. So you can take an index card, write something on it, put it on the board, and people hopefully will show up to that open space. You can also find other open spaces and go attend them. So there are 9 open spaces at any one time. 9 plus 5 is 14, so there's 9 open spaces, 5 talks, all happening at the same time. So 13 divided by 14, you are missing out on at least 92% of PyCon at any one time. So if you're having FOMO, if you're fearing missing out, I want to let you know there are open spaces that you should go to because the talks are recorded. The open spaces are not recorded. So do at least 1/3 open spaces would be my recommendation, if not more than that. Also, it is okay to hang out in the hallway and just talk to people. You don't need to be somewhere all the time because the reason we have these conferences is so that we can be in person actually meeting each other. The talks we can always watch later. I would also encourage you, host an open space, do the hallway track, and give a lightning talk if you can. There are lightning talks, which are one of the best parts of the talks to see. You can give your own lightning talk. There's going to be a sign-up board. You can give a lightning talk on anything. In fact, I gave a lightning talk at DjangoCon last year on giving a lightning talk. You can give a lightning talk on writing a blog post if you want. I can link you to that talk on giving a lightning talk later, or you can look it up. Go on Twitter. If you do not have Twitter, I would recommend at least getting an account and searching the hashtag PyCon 2017. It's not last year. And search for PyCon. PyCon or PyCon 2017. Twitter supports this capital OR for searching to see what's going on. People sometimes say, hey, does anyone want to do dinner in an hour? You might meet someone new on the hashtag just because you happen to be on there seeing that someone wanted to meet someone new and do dinner. Also, there is a newbie's breakfast, a newcomer's breakfast. So there's a newcomer's breakfast. It is new this year. I think it's tomorrow and the next day. So in the morning, go to the newcomer's breakfast. People will talk to you about what goes on at PyCon. So all the things I just said, they'll probably tell you even more of that and better things. There is opening reception tonight. There's also swag bag stuffing this afternoon, which is something you can volunteer for. It is a giant human assembly line where we stuff all the things in the swag bags that we are all going to receive tomorrow. So you can be part of that effort. I'm going to be there, and a lot of other people are going to be there. It's going to be pretty fun. Try to meet one new person at breakfast every day and at lunch. Yeah. Sit at a table where there's at least one person you don't know. Sit next to that person and introduce yourself. Oh, the talks? The talks, yeah, it's first come, first sit in the room. The rooms are pretty big usually. But if there's not a seat, you can often stand in the back of the room. They're not like this in the sense that they're not interactive. Usually you're just watching, which is the reason often you can just watch them on YouTube afterwards, unless, of course, you want to ask the speakers questions, which is always a nice thing to do. Speakers, a lot of times, like being asked questions in the hallways afterwards, too. No, they're usually not like this kind of tutorial session. If you see someone with an Ask Me a Question badge, you should ask them a question. If you see someone with a conference staff thing on their bottom of their badge, they might know what they're doing, or they might not know what they're doing, but you could ask them a question anyways. I don't know what I'm doing, but you're welcome to ask me questions. If you find someone wearing bright headgear, they might be more likely to answer your questions. This is what I've been told. I don't know why. Kojo. Ask Kojo a question.
I'm not like an ask a question person, but yeah.
Also, if you see me or one of the TAs in the hallway, feel free to walk up to us and just talk to us about stuff. We are happy to, help you through your PyCon first time here. And if you are attending the sprints, if you're not attending the sprints and you can attend them, please do so. I would highly recommend them. there is an intro to the sprints the night before. So the last night of the talks, there's an intro to the sprints in the afternoon. I would highly recommend going. Even if you do not know how to code, you can go to the sprints. I got this. I got this for contributing to an open source project. Beware gave me a challenge coin because I contributed to it. They are one of the open source projects that is particularly friendly to new programmers. In fact, the thing that I contributed was I updated the homepage of their website to change the text on it to actually describe what their project did better. I didn't write any code. You don't have to write code to contribute to an open source project. You can do marketing help. You can do design help. There's all sorts of things you can do that helps. So that is everything. If you would like to do lunch together, I guess let's all walk over there together. We can talk about, the material, PyCon, anything else. In the meantime, any final questions that you'd like to ask before we wrap up here? All right, so you can ask them individually. We'll walk together, but that's everything. Thank you. So if we want to type text at the Python REPL, we can put it in quotes. This is a string. Strings are the way that we represent text as opposed to numbers. Python does not care if you use double quotes or single quotes. So double quotes work, single quotes work. You have to make sure that you use double quotes and single quotes consistently, though. If you type PyCon starting with double quotes, ending with a single quote, that doesn't work.
Question though, when you're
Yep.
using your double quotes, if you respond to just the single text,
Yeah,
you would put in single text, it's also going to give you the single text.
that's a good point. So we put in double quotes there. It gave us back single quotes. I put in single quotes, it gave me back single quotes. So Python doesn't care at all what quotes we use. When it spits something back to us, it's going to spit it back in the way that it feels like it should. If I were to say, I don't know, it puts that in double quotes. It puts that in double quotes because it's got an apostrophe in there, and it decides, oh, it would be easier for me to show double quotes around that. If I put double quotes and single quotes, that's going to be hard for me to do. We're going to try that later, maybe. If I put double quotes and single quotes in a string, it will do something a little bit different. In fact, we'll get an error. That is not something Python can handle. If you wanted to do that, you have to put backslashes before those things. And then Python still decided to do something different. It put it in single quotes and put a backslash before that apostrophe. So Python does what it wants. Python does what it wants. We type in a string in one way, it's going to give us a string in whatever way it feels like giving it to us. All that we care about, though, is that it's a string. What would happen if I add a string and a number together? What do you think? What is your guess? Who thinks we're going to get a string back? Who thinks we'll get a number back? Who thinks we're going to get an error of some sort? Who thinks we're going to get something else? Okay, so we get an error. This is different between different programming languages. Python does not want us to try to use plus on strings and numbers. It doesn't know how to handle that. If we wanted to add to a string with something else, we have to add it to another string. Now notice it doesn't matter whether I'm using single or double quotes here. If you take two strings and you add them together, this is smushing them together. This is called concatenation. Concatenation basically just means you're taking two things and smashing them together. All right, now it's your turn. So back to the website. This time we're on strings. So today, hopefully, you will get a lot of experience typing things, not just at the REPL, but in Python files. We will be making Python programs soon here. If you have any questions at all, put up a red sticky. If you get through all of these exercises, put up that yellow colored sticky.
and then it'll help you with your programming problems. And when you walk through the expo hall, some of the sponsors usually have those rubber ducks, so I can highly recommend grabbing one and putting it on your desk and actually trying it out because it does work.
So I asked someone else to explain it so that you would believe that it's a real thing. And it didn't just make that up. It is on Wikipedia. So if you go to Wikipedia, there is a rubber duck debugging article. This is a real thing. So Charlie's currently passing out rubber ducks to you. You all get a rubber duck today. You will not need these rubber ducks. Some of you get pairs. It's for pair programming. You will not need these rubber ducks in the room today because you have teaching assistants, and they can be your rubber ducks. Teaching assistants who are here right now, we've got Anna Salsky, Kojo, Melanie, Charlie, who's currently walking around with ducks, and I think we might have another TA come in later to help us out. So if you need help today, we're going to use a sticky system. During the exercises, and we will have multiple exercise breaks, put up a red sticky like this to note that you need some help. We use stickies because if you are raising your hand, it is difficult to type, unless you are good at one-handed typing, but it is difficult to do one-handed typing. So we're using stickies so that you can easily type while asking a question at the same time. Or wanting someone to come over and be your rubber duck to just, be there as you try to walk through the problem. We have plenty of TAs, so do not be afraid to use your red stickies. We are happy to be your rubber ducks. All right, so let's get started here. I do not use slides when I teach. So we are going to be live coding. You do not need to be typing in everything that I type in. Everything I type in, for the most part, is going to be on the website. You can look at it afterwards. I am going to pass the torch to you every once in a while. We're going to work through exercises. And that is your turn to type. And at that point, you'll work through exercises. Afterwards, we might go through one together if we have time. You're welcome to go look on the website, to Google things, to go to Stack Overflow. That is not cheating. In the real world, probably half of the code that you write is copy-pasted from Stack Overflow. Some people may not like the fact that I say that, but I don't think they would deny that it's true. So in Python, we can get to Python by opening a command prompt, typing Python 3.6. There's various ways to do this. On Windows, Mac, and Linux, it's all a little bit different. If you can't get to your Python REPL during the exercise break, put up a red sticky and ask a TA for help, please. We have math. We've got numbers. We have arithmetic with both integers and decimal numbers, which we call floating point numbers for weird historical reasons. Yeah, you should. Thank you for pointing that out, Kojo. You could just look at rubber ducks all day, but it's nicer to look at code. So 2 plus 2 is 4, 1.4 plus 2.25. Still have a website up. Thank you. Okay, now we can see my code. So Python has math. I typed Python 3.6 to get into this thing. So this is the Python shell. We also call this the Python REPL. Does anyone know what REPL stands for? So I don't think my TAs know what REPL stands for either. So REPL, I looked this up at some point. I can't remember whether it's read evaluate print loop or read execute print loop. Python reads what you are typing. It executes what you're typing when you hit enter. It prints out the result, and then it loops, meaning it is waiting for us to start over, to start typing again and do something else. So this is the read, execute, print loop, the REPL. Python shell, Python REPL, either of those names. All right, 2 divided by 2. What do you think this is going to give me? What's your guess? 1, all right. 3 divided by 2, what do you think? 1.5. So Python 3, Python 2, this changed a little bit. Python 3 does what we'd expect here. 3 divided by 2 is 1.5. If you don't get 1.5 later when you type this, you're in Python 2. We need to jump into Python 3. If you do want to round things down, you can use //. I don't know why you'd want to do that, though. What's your guess? What do you think this might do? 2 * 10. 2 raised to the 10th power, 2 raised to the power of 10. So maybe this is an exponent? Yeah. So 1,024, that's 2 to the 10th power. What do you think this is going to give me? An error? Maybe it'll break my computer? Hopefully it doesn't break my computer. I want to go at least 20 minutes without breaking my computer. Gives me a really big number. So Python does not have integer overflow, which some programming languages have. We have really big numbers, and that's fine. So one of the great things about Python, as opposed to other programming languages you might jump into, you might start learning, is it tends to be a little bit easier to work with when you're getting started. We don't have to worry about problems like that really big numbers might not work. All right, so I know that was really brief here, but I'm going to pass it to you now. It is your turn to now go to the REPL and type some things in. So if you could go to the website, it's intro2017.trey.io, and go to introduction and that first your turn REPL. If you could go there and work through, we've got 4 exercises. By the way, I do not plan on you being able to get through all of the exercises in any given exercise section. These are here for you to work through after the tutorial. If you do get through all of them, if you're fast at working, that's fine. Put up, actually, if you do get through all the exercises, if you could put up a yellow sticky, I don't know what color this is, the sticky that's not red, if you could put that up on the top of your laptop, if you All right, so who does not have, or rather, if you do not have Python 3.6 installed, you're not sure if you have it installed, if you could put up a red sticky, or if you've already talked to a TA about the situation of your computer, that's fine as well. If you don't have Python 3 installed, specifically 3.6, there are going to be some bumps, some hiccups during this, because I'm using Python 3 syntax. Python 2, Python 3, they are different programming languages. They are extremely similar, but there are some big differences between them. In that Python 3 is backwards incompatible with Python 2. If you've got Python 2 code, you can't run it on 3 and vice versa. You can run code on both, but it's got to be a subset of the two. 3.6 added some new features that I will be using today. So if you're on 3.5 or earlier, then you're maybe going to have some struggles as well. So if you cannot access the website, that's intro2017.trey.io, intro2017.trey.io, please put up a red sticky, let a TA know. There were internet issues yesterday. I think they fixed them today, but we will find out. If they haven't, you can always bring up the website on your phone. There actually are a couple things you need to download there that we're going to go over right now, but for the most part, you can bring it up on your phone. Okay, let's actually go over those things you need to download right now, just to make sure that if we have internet issues, we get them settled the first 10 minutes here. So on the website, on the very home page, if you could scroll all the way down to the bottom, I'm going to bring that up real quick here. All the way down to the bottom of the page, and click on each of these files and download them somewhere. They can be in your downloads folder, wherever you want them to be. You're going to copy paste those every once in a while throughout the day. Now, we only have 3 hours together, and it's difficult to learn a new programming language in 3 hours. It's difficult to learn programming in 3 hours. So we are going to try to make some progress, but it's going to be difficult progress. You will have hopefully written code by the end of the day. I can't promise you how many lines of code you will have written, but you will have written at least a line of code. Hopefully it's a line of code that does something. Maybe not the right thing, but something. So when doing a tutorial or any kind of class for any audience, I like to know who I'm working with. And I don't know any of you yet. So I'd like to know who has been to PyCon 3 or more times, including this year. You've been to PyCon 3 or more times. Okay, no one in the room. That's good. Not that I would feel bad if any of you have been here a lot. PyCon's a wonderful place, but I was assuming you're pretty new to PyCon. Who's been to PyCon 2 times, maybe last year and this year? Been to PyCon this year and another year? Okay, who's their first PyCon this year? Excellent. Awesome. So another set of questions. Who has written in any programming language over 1,000 lines of code? Okay, more of you than I expected. So we might have different definitions of new programmers here, but that's okay. So who has written between 100 and 1,000 lines of code? Okay. Ever, in any programming language, 100 to 1,000 lines of code. Okay. Who's written less than 100 lines of code in any programming language? You're pretty sure you've probably written less. Okay. So overall, I have the feeling that we might be a little bit more experienced than I'm expecting here. That doesn't necessarily mean you're not going to struggle, because often things go faster than we'd expect them to go in terms of learning a new programming language. In Python, who has written over 1,000 lines of code? Okay, all right, so at least we're, for the most part, pretty new to Python here. All right, at this point, actually, I would like to bring out the rubber ducks, I think. I didn't ask this beforehand. I don't want to put any of you on the spot. Do any of my TAs want to explain rubber duck debugging? Okay. Yeah, Anna doesn't have a mic, so this might not be on the video. Sorry,
I'll
but
just try to speak out loud. So, who of you know what rubber duck debugging is, or who of you have heard about it? Not many. So, you all know those little bathtub rubber ducks, and the concept is that you put a rubber duck on your desk and you explain your programming problem to it. It sounds a little bit crazy to do that, but it's actually just like explaining something to another person. The rubber duck just can't talk back. And by speaking your problem out loud, you will either find the solution, because your mind starts digging more into the issue, or you will at least be able to phrase it more precisely so you can Google it. Sometimes when you have programming issues and you don't quite know what the problem is, you can't type a whole paragraph into Google. When you Google something, it needs to be really precise. And so by explaining it to your rubber duck, you'll kind of realize in your mind a little bit.
get through all 4 of the exercises. That would be excellent. Then I know that it might be time for us to move on. If you need any help at all, whether bringing up Python, getting into the REPL, typing something out, or figuring out what one of the exercises means because it's not worded very clearly or you're unsure, please put up a red sticky, and one of the TAs or myself will float around in the room to help you out. Yeah,
Is everyone able to get to the website? Is that fine for everybody?
So I don't see any red stickies. A reminder that we're happy to be your rubber duck. If anyone is having trouble getting the files on your computer, I've got them on a USB stick. You having trouble? Excellent. Yep. Yeah, besides those files, you should be able to access the website on your phone. All right, we're going to move on to the next section at this point. So hopefully you got to play around in the repo a little bit. There weren't really any exercises there that we have answers to. That was mostly just playing. We will occasionally go through answers. Who is the type of person who likes to ask a lot of questions? Okay. If you are not the type of person who likes to ask a lot of questions, I would challenge you to ask at least one question today. If you ask at least one question today, I think we should have a question every 8 minutes or so. It's hard to do math in my head. I could use Python, but I don't even know what I'm dividing. Yeah, so we should have a lot of questions if you all ask at least one question today. If you're the type of person who asks a lot of questions, and you feel like you're the only one asking questions, pause for 10 seconds or so, and if no one's asked a question still, feel free to ask your question. All right, what do you think this is going to do? I'm going to type Trey. This is not a number. What's your guess? An error? Yeah, Python does not understand my name. I am not built into Python. We're going to jump to the next section at this point. Any questions so far? All right, make sure you've got that one question that you're going to ask ready at some point. Okay, so let's jump back into this. All right, who has done, I want to say math before, but everyone's done some kind of math. Who's done algebra before? Who remembers algebra? X equals something, Y equals something, variables. So in Python we have variables as well. So I can say X equals 4, X times 3, and that gives me 12. I can take a bunch of variables and add them together as well. So this is not my packing list for Python. This would be a little light if this is what I was packing for Python. We've got some socks, shirts, shorts, and we add them together, we get clothing. What should clothing be here? Yeah, it's 4. So we can use variables as placeholders. Variables point to a thing, and it's basically a placeholder for that thing. So if we've got the number 2, we can use the number 2, or the variable that represents that number 2, say socks here. Or we have the number 1, both shirts and shorts point to the number 1 there. All right, I'm going to throw it back to you at this point again. So lots of typing. I'm trying to make this as hands-on of a tutorial as possible. The reason for this is if I show you things and you don't type them, you haven't learned anything at all. You've seen me do something, but until you've applied something, you haven't learned it. So we're at your turn variables at this point on the website. If you have any questions, put up a red sticky. If you get through all 4 of these exercises, put up a yellow sticky. Right after this section, we're going to finally make our own Python programs. apologize that wasn't very long, but we're going to get back to it. Any questions at the moment about anything we've done so far?